Welcome to our Preboard 1 lecture video, and this time we'll have the answers and solutions for problem set 2 plane geometry. Now let's start with number 1. A triangular piece of wood having a dimension of 130 centimeters, 180 centimeters, and 190 centimeters is to be divided by a line bisecting the longest side drawn from its opposite vertex. The area of the part adjacent to the 180 centimeter side is letter A, 5,126 square centimeters, letter B, 5,162 square centimeters, letter C, 5,612 square centimeters, or letter D, 5,216 square centimeters. So for the drawing, so we have here the triangular piece of wood. Let's put the dimensions. So since this is the longest side, let's put okay. So let's have this as the longest side, 190 centimeters. Then this is the second longest side, 180 centimeters, and the shortest will be 130 centimeters. It says here, it is to be divided by a line, says there, divided by a line bisecting the longest side drawn from its opposite vertex. So the longest side is being bisected. Now when we say bisected, meaning that line is being divided into two equal parts. So the line here, the longest side, is bisected by drawing a line to the opposite vertex. Therefore, this now becomes 95 centimeters and then 95 centimeters. Now, what is being asked in this problem is the area, the part adjacent to the 180 centimeter side. Adjacent to the 180 centimeter side is this one. So we have here. So this portion here is what we will look for the area. So how do we solve this? Now, if you look at this intently or closely, we can have or we can get the area of this by, well, we can use here the area is equal to, so we have here, area is equal to 1/2 of the sides, the adjacent sides of the angle theta. Okay, so the angle theta here, we put here an angle theta, this side here. So let's just erase. Okay. Angle theta. So that when we are looking for the area, we have their area is equal to 1/2 of the 180 centimeters times the 95 centimeters sine of the theta. So we are going to look for the value of theta. Now, how do we get the value of theta? Well, we can have the cosine law. Since all sides are given for the three sides, so we can determine the value for theta. Why cosine law? So we have here, the opposite for theta here is the 130 centimeter side. So 130 squared is equal to 180 squared plus 190 squared minus twice of the adjacent 190 cosine theta. Thus, we get the value for theta as, so that is 41.028 degrees. So I am using the Casio calculator. So you can actually inverse cosine this one. Okay. So therefore, since we have now the theta, A is equal to 1/2 180 times 95 sine of 41.028. Therefore, the area here is equal to 5,612.457 square centimeters. Okay? So the correct answer is letter C, 5612. The nearest answer is C. Or we can have another solution for this if you are seeing the other solution. So here you can have here's formula. So we have here x. We can find the value of x here by having, since we were able to get the value of theta, then we can find now x. By using cosine law, x squared is equal to 180 squared plus 95 squared minus 2 times 180 times 95 cosine of 41.028. X will be equal to, okay, so that is 125 centimeters. Having here the value for S is equal to 180, so all three sides, 180 plus 95 plus 125, all divided by 2, that is equal to 200 centimeters. So area is equal to square root of 200 times 200 minus 180, then we have 200 minus 95, then we have 200 minus 125. So square root. Let's see if we get this exact value. So what that is 5612.486 square centimeters. Still the answer, nearest answer is letter C. So that's for number 1. Next, for number 2. If the sides of the parallelogram and unincluded angles are 6, 10, and 100 degrees respectively, find the length of the shorter diagonal. We have letter A, 10.63, B, 10.37, C, 10.73, D, 10.23. So we have here the drawing of the parallelogram. So the given here is 6. So the side, obviously 6 will be on the shorter. So this is 6. Then the longer will be 10. Then this 100 degrees here will go on the obtuse angle here, 100 degrees. Not at this portion here, because this portion here is acute angle, obviously less than 90. Okay, so find the length of the shorter diagonal. This parallelogram has two diagonals. We have the longer diagonal and the shorter diagonal, which is being asked for in the problem. So how do we solve this? Given all sides, we are looking for the value of x. So this x here. So we can use cosine law. by looking for the value of theta, then theta here. Actually, we can already find theta because this is a parallelogram, so meaning this angle here is also 100, then theta, theta. Therefore, the value of theta will be 360 degrees minus twice of 100 degrees divided by 2. Okay, so theta is equal to 80 degrees. So that's correct, it's less than 90 degrees. Now to find for x, we have the cosine law, x squared is equal to the adjacent to the angle theta. So we have there 6 squared plus 10 squared minus 2 times 6 times 10 cosine of 80 degrees. So x is equal to square root of 6 squared plus 10 squared minus 2 times 6 times. Okay, so x is equal to 10.73 units. So the answer here is 10.73, that is letter C. Okay, so that is for number 2. For number 3, a corner lot of land is 35 meters on one street and 25 meters on the other street. The angle between the two lines of the street being 82 degrees. The other two lines of the lot are respectively perpendicular to the lines of the street. What is the worth of the lot if its unit price is 2,500 pesos per square meters? Letter A, 1,978,456 pesos. Letter B, 1,588,045 pesos. Letter C, 2,234,023 pesos. Letter D, 1,884,050 pesos. So as for the drawing, so these are the streets. Then we have the corner lot here, which is 35 meters on one street and 25 meters on the other street. So obviously the shortest one will be the 25 meters. We have here the 35 meters. So there you go, 25, 35. Then the angle between the two lines is there. The angle between the two lines of the street is being 82 degrees. So the angle here is 82 degrees. The other two lines of the lot, these ones, okay, the other two lines of the lot are respectively perpendicular to the lines of the street. So it is perpendicular to the lines of the street. So this is 90 degrees, 90 degrees, 90, 90. So what we're looking for here is the area of this lot. Find the area. How do we do that? Now, this is one tricky problem, I admit. So let's find a way to find the area of this one. Actually, what I think would be the answer for this, although I know already the answer for this, but what we're looking for is how do we solve it. So this is one of the one solution that I found. So I will divide this into two and then find the areas 1 and 2. So I'm going to find the area 1 and area 2. And then, first, we will need to find what is the value of x, the y here, and the z, the length of the other two sides of the street. Because what I'm planning to do is to find the areas A1, A2 by getting the area of the triangle, because since this is perpendicular to the street, so I'm going to find the area for the right triangles A1 and A2. Okay, so let's see, how do we get it? So here we can find the value for x. Let's equate them. Okay, so let's put here the angles 82. So if I put here, okay, the smaller one, I will put here theta. If I put here theta, and then if I put here 82 degrees minus theta, then we can solve for the x by equating. We will be equating x. So I hope you get the idea. Cosine 82 minus theta, because it's a right triangle already. So cosine law, so katawa. So cosine theta, 82 minus theta is equal to the adjacent 25 meters over the x, the hypotenuse x. So we will have the value for x. For x, we have 25 all over cosine 82 minus theta. Then, for the other triangle at area 2, we also have here the cosine theta is equal to the adjacent 35 divided by the hypotenuse x. So x is now equal to 35 all over cosine theta. Therefore, we will now equate x. So we have here 25 all over cosine of 82 minus theta is equal to 35 all over cosine theta, so that we will get a value for the theta. So theta now is equal to 30.15 degrees. If that is the case, if theta is equal to 30.15 degrees, then we will now be able to find the values for z and y. To find for z, we will be using tangent because it is opposite over the adjacent. Now to find y, we will use tangent theta is equal to the opposite over adjacent. Okay. So we have here tangent of 82 minus 30.15 is equal to the opposite z all over the adjacent 25. So z is now equal to 31.83 meters. Now for the other one, we have tangent 30.15 is equal to the opposite y all over the adjacent 35. So y now is equal to 20.33 meters. Now that we have z and y, we can now have the area by using the area of a triangle 1/2 base times height. The area of the triangle for A2, we have the 1/2 base times height. Okay, so area total now is equal to A1 plus A2, 1/2. The base is 25 times the Z of 31.83 plus 1/2 the base of 35 times the height of 20.33. So area total is now equal to 753.65 square meters. And what is being asked in the problem is the worth or the cost of the lot. So unit price, So the price of the lot is 2,500 per square meters multiplied with 753.65 square meters. So price now equal to 1,884,125 pesos. So what choice is it nearer? So that is letter, so what's that again? 1884. So the one nearer to it is letter D. 1,884,050 pesos. So that is for number 3. Let's go to number 4. A polygon has 170 diagonals. How many sides does it have? A, 20, B, 18, C, 25, D, 26. We need to take note that the diagonal of a polygon is the line segment joining two non-adjacent sides, and the formula for it is, so the number of diagonal is equal to the number of sides all over 2 n minus 3. So from the given, we have 170 diagonals. It's looking for the number of sides. So what's the value for n? You take the long method here. So we have here 340 equals n squared, 3n, n squared minus 3n minus 340. But you can use directly, you can solve it directly in the calculator already. So n is equal to 20 sides. So the answer is letter A. So that's for number 4. Now let's go to number 5. The corners of a 2-meter square are cut off to form a regular octagon. What is the length of the sides of the resulting octagon? So we have a square and then the sides. So here is the square, a 2-meter square, and then the green ones here. So the side of the octagon. So what is the length of the sides of the resulting octagon? So that means we have an equal sides of 8. We have number 1 here, 2, 3, 4, 5, 6, 7, 8. So we have 8 sides. How do we solve this? So So if this is 2 meters here, therefore this portion here is also equal in length. So if we draw another triangle here, so let me redraw another triangle. Okay. There you go, a right triangle. If this is x, therefore this is y and y. Then, by Pythagorean theorem, we have there x squared is equal to y squared plus y squared. So x squared is equal to 2y squared. Y is equal to square root of x squared all over 2. Therefore, y is equal to x all over square root of 2. Therefore, what happens here is that this is x over square root of 2, x, and then x over square root of 2. Therefore, 2 meters is equal to, so we have there x over square root of 2 plus x over square root of 2. So using the calculator here, we have here x is equal to 0.828. So we have there x is equal to 0.828 meter. From the choices, right answer here is letter D, 0.828. So this is number 5. Next, let's go to number 6. In the figure shown, MAN is a tangent to the circle of center O. If angle BAN is equal to 70 degrees, find theta. Letter A, 220 degrees. Letter B, 210 degrees. Letter C, 140 degrees. Letter D, 250 degrees. So here it is, says there, the angle BAN is 70 degrees. Oops. Okay. So what we're looking for is the theta here. Now, how do we solve this? Now, if you see the triangle CAB here, and then we have these lines here. These are actually the radius of the circle, which are equal to each other. Therefore, the angle here is also equal to the angle there. So for this triangle, the angle alpha is equal. Therefore, if we look at this again, this line here and the line for MAN, it's actually 90 degrees. It's perpendicular. So, can conclude that alpha plus 70 degrees is equal to 90 degrees. Because whatever line is tangent to the circle, the radius will always be perpendicular to it, to the point of intersection here. Will always be perpendicular to the tangent line. Therefore, alpha is equal to 20 degrees. If alpha is equal to 20 degrees, then we will be able to find the angle here, beta. So, we have here 2 alpha plus 1 beta is equal to 180 degrees. 2 times 20 plus beta is equal to 180 degrees. So, beta is equal to 140 degrees. If beta is equal to 140 degrees, therefore, we can now find theta because beta plus theta is equal to 360 degrees. 140 plus theta is equal to 360. Theta now is equal to 220 degrees. So the right answer here is letter A, 220 degrees. So that's for number 6. Next, let's go to number 7. Find the area of the shaded portion here. A, 50 pi, B, 25 pi, C, 20 pi, or D, 30 pi. I find this actually tricky, but finally I was able to find the right solution because we already know the answer here, but we need to find the right solution. Looking at this from the center here, so this is actually considered as tangent to the inner circle. So if I put here a radius r, it will be perpendicular. Let's have a bigger figure. Oh, cannot find a bigger figure. Okay. So just as I said, from the center, we have the radius r perpendicular to the tangent. This is the radius for the inner circle or the smaller circle. Then we also find here the radius for the outer circle or the bigger circle. So what do we find here? So it's actually a triangle. So it's a triangle, a right triangle, which is 5 R, big R. Now, to find actually the area, the shaded portion, we have here the formula area is equal to the area of the bigger circle pi r squared, meaning if we take the bigger circle here, so we have the full circle here. We're taking that area pi r squared minus the area of the smaller circle, that is pi r squared. That is, area is equal to pi r squared minus r squared. So that is equation 1. Then from the triangle, we have here, using Pythagorean theorem, the hypotenuse squared is equal to r squared plus 5 squared. R squared minus r squared is equal to 25. Then, at equation 1, we find here that A is equal to pi. Substitute this value, that is 25. Therefore, area is equal to 25 pi. So the right answer for number 7 is B, 25 pi. Next, number 8. A piece of wire having a total length of 72 centimeters was cut into 2 unequal segments and bent to form 2 unequal squares. If the total area of the squares is 180 square centimeters, what is the difference in the lengths of the 2 segments? Letter A, 24 centimeters, B, 16 centimeters, C, 32 centimeters, or D, 28 centimeters. So we have here the piece of wire divided into 2, was cut into 2 unequal segments and then formed 2 unequal squares. So have here squares of area 1 and area 2. So that means the dimension for this is, let's say this is x, then this is y. Okay, then says there, if the total area, says there, the total area of the squares is 180. So area total is equal to A1 plus A2 is equal to 180 centimeter squares. So for area 1, we have there x squared plus for area 2, y squared is equal to 180 centimeter squared. So this becomes your equation number 1. Then, what else? The piece of wire has a total length of 72. So if the dimension for the squares are x and y, therefore the length of these wires are 4x, meaning the perimeter of the square, and then 4y. And then the total length, 4x plus 4y, is equal to 72. Then let's take y is equal to 72 minus 4x divided by 4. Y is equal to 18 minus x, and that is equation number 2. And what's being asked in the problem, by the way? What's being asked is the difference in the lengths of the 2 segments. So what is being asked is, what is 4x minus 4y? Question mark. So what do we do here? We substitute equation number 2 to equation number 1. So from equation 1, we have there x squared plus y, which is 18 minus x squared is equal to 180. And using your calculator, you can solve this directly in the calculator already. Then find x. Or you can expand this and then perform operations and then use the quadratic formula. So x is equal to 12 centimeters. At equation 2, you find that y is equal to 18 minus 12. So 18 minus 12 is 4 centimeters. So, that is 6. Sorry, that is 6 centimeters. Therefore, 4x, which is 4 times 12, minus 4y, which is 4 times 6, is equal to 24 centimeters. So the right answer here is letter A, 24 centimeters. That's for number 8. Let's go to number 9. Determine the area of a regular hexagon inscribe in a circle having an area of 170 square centimeters. So we have here letter A, 169.8, B, 124.1, C, 148.2, D, 140.6. For the figure, we have here the regular hexagon. When we say regular hexagon, meaning it has equal sides. Then have here from the center, since the regular hexagon is inscribed. When we say inscribed in a circle, it is inside a circle. So means the radius, the circle here is equal. Then we have here the what we're looking for is the area of the regular hexagon. So if we're looking for the area of the regular hexagon, area hex is equal to the area which is 1/2 of the two sides. The two sides are R and R, or R squared. Then we have sine of theta of the adjacent side. So we have here theta. Then since it is a hexagon, so whatever area here is, whatever area we compute here will be multiplied with 6. So it is multiplied to 6. Then what's given here is that area of the circle. So what we need to find out is the R and the theta. Now for the theta, it's quite easy because it's a regular hexagon. So you just have to divide 360 degrees with the number of the triangles, which is 6. Number of sides, which is 6. Then we have here 60 degrees. So we have the theta. Then for the R, given the area of the circle, which is 170, area of the circle is pi r squared. So r is equal to 107, or r is equal to square root of 170 divided by pi. So that is 7.36 centimeters. Therefore, area of the hexagon now is equal to 1/2 7.36 squared sine 60, okay, sine 60 degrees multiplied with 6. So area is now equal to times 6, 140.74 square centimeters. From the choices, the nearest is letter D, 140.6. So that's for number 9. Okay. Then the last one, we have number 10. The sum of the sides of two polygons is 12, and the sum of their diagonals is 19. The polygons are letter A, pentagon and heptagon, B, both hexagon, C, quadrilateral and octagon, D, triangle and nonagon. Okay, so let's solve this. It says here, so now remember the formula that we used in the previous number. You have there the formula D is equal to n over 2n minus 3, where n is number of sides and D is the number of diagonals. So it says there the sum of the sides of two polygons is 12. So n1 plus n2 is equal to 12. Then let's have n1 is equal to 12 minus n2. Let's have this as equation 1. Then, it says here, the sum of their diagonals is 19. So that means d1 plus d2 is equal to 19. Then, using the formula for d1, we have there n1 over 2 times n1 minus 3 plus n2 over 2 n2 minus 3 is equal to 19. So we have here, so remove n1/2. So this is 1/2 n1 minus 3 plus n2 minus 3 is equal to 19. Oops. So this is equal to 19. Therefore, this is n1 squared minus 3n1 plus n2 squared minus 3n2 is equal to 38. 19 times 2 is 38. So this is equation number 2. Then, substitute equation 1 to equation 2. We have here n1 squared. Okay, so we can have this as n2 so that we get n1 first. So I just like it to be in order like that. So we have there minus 3n1 plus, for the n2 squared, we have there 12 minus n1 squared minus 3 times 12 minus n1 is equal to 38. If I am going to use long method, then we have here n1 squared 3n1 plus 144 minus 24n1 plus n1 squared minus 36 plus 3n1 is equal to 38. Cancel 3n1. We have here 2n1 squared minus 24n1 plus 70 is equal to 0. So using the quadratic equation, or by using your calculator, direct from your calculator, we have n1 is equal to 7 and n2 is equal to 12 minus 7. Remember from equation 1. So from equation 1, we have there n2 is equal to 12 minus 7, n2 is equal to 5. Now, what kind of polygon is n1 is equal to 7 and n2 is equal to 5? Therefore, they are heptagon and 5 sides, that would be pentagon. So the right answer here is letter A, pentagon and heptagon. So that's for number 10. So that's all for Preboard 1 problem set number 2.